Hello everyone. In this video, I am going to explain the concept of impact collision. This topic is from the module 6 kinetics of particle. And then we will solve the problem on the direct impact and the oblique impact. So let us see what is meaning of impact. Impact means when two bodies collide, they exert very large amount of force on each other during very small interval of time. This phenomena is called as impact. So here you can see two objects, they are approaching each other. So the object A has velocity towards the right, VA, and the object B has velocity VB towards left. So these are the velocities of the object A and B before the impact. When the objects start approaching each other, at one point they will have the collision, and after the collision, the direction of velocity and the magnitude of velocity will change. So this phenomena is called as an impact. So let us understand the process in detail. So these are the position of the objects before impact. So this is a VA and this is a VB. With this velocity VA and VB, the object will approach each other. This is the point exactly at the impact. So after impact, so this is the impact. And this is the velocity after impact. So direction of velocity will change after the impact. So object will start moving with a different velocity VA dash and the VB dash. Okay. So during the impact, the momentum is constant. It means that the momentum before impact it will remain same momentum after impact. So the total momentum of the object A is ma into VA. This is before impact plus mb into VB. This is equal to after impact mass will remain same, just velocity will change. So it is VA dash plus mb into VB dash. Okay. So the total momentum is conserved during the impact. So there is an exchange of momentum, and because of that, the velocity will change before impact and the after impact. So impact is classified into two types. The first is the direct impact and second is the oblique impact. So let us see what is the meaning of direct and the oblique impact. So in case of direct impact, the velocities of the bodies are directed along the line of impact. So here we can see the object A and B, their velocity is exactly along the line of impact. So this dotted line, this is called as a line of impact. So basically the line of impact is the imaginary line that joins the common normal at the contact point. So what is meaning of common normal? Let us take this is the contact point which is on the mass A. So this is the center of gravity for the mass A. This is the contact point with the object B. So at this point, if you draw a tangent line, so this is the tangent line. So if you draw the perpendicular to the tangent, it will become the normal. Okay. So the line of impact means it is the imaginary line that joins the common normal at the contact point. Okay. So if the velocities of the two bodies, they are directed along the line of impact, it is called as a direct impact. So here the velocity direction of A, this is VA, and this is the velocity direction of B. So this is a VB. Both these velocities, they are exactly directed along the line of impact. So therefore, this is called as a direct impact. In case of oblique impact, the velocities are not directed along the line of impact. So here you can see, this is the before impact VA and the VB. Okay. So these velocities, they are inclined at some angle theta B and theta A with respect to line of impact. So this is referred as a oblique impact. So in the oblique impact, velocities before impact and after impact, they are directed at an angle with respect to line of impact. So here the line of impact is shown. So this is the line of impact. So you can refer this velocity, it is directed at some angle. Let us take this theta A. And this is theta B. Okay. So you can see the process of oblique impact before collision and after collision. So after collision, two objects, they move in different direction at different angles. So this is theta A dash after collision and this is theta B dash after collision. Okay. So this is about the oblique impact. So when we solve the problem on the impact, we have to use two equations. The first equation is the conservation of momentum equation and the second equation is the coefficient of restitution equation. Okay. So basically when we solve the problem on the impact, we are interested in the relation between velocities before impact and the after impact. So this is the velocity of two objects, VA and VB before impact. So this is the point of impact. And two objects are separated out after the impact and they start moving with the different velocities. So let us take velocity after impact is VA dash and the VB dash. Okay. So we can determine this value VA dash and VB dash by using the momentum conservation equation and the coefficient of restitution equation. So conservation of momentum means the impact momentum before impact this is equal to momentum after impact. So total momentum before impact is momentum of object A. So it is MAVA plus momentum of object B, MBVB. This is equal to after impact is MAVA dash new velocity plus MBVB dash. Second equation we should use is the coefficient of restitution. So it is given by E is equal to the change in velocities after impact. So it is VA dash minus VB dash upon change in velocities before impact. So it is VB minus VA. So basically this coefficient of restitution, it gives an idea about the exchange of the kinetic energy. Okay. So E value, it ranges from 0 is the minimum and maximum is 1. It is similar to the coefficient of friction. So when E is equal to 1, this is called as an elastic impact. So meaning of elastic impact is the kinetic energy loss, it is 0 in case of elastic impact. So total kinetic energy before impact, this is equal to the kinetic energy of the system after impact. When E is equal to 0, this is called as a perfectly plastic impact. In case of plastic impact, both the objects after impact or after collision, they move with the same velocity. Okay, so after impact, in case of plastic impact, VA dash, this is equal to VB dash. So we can take this as a V dash. Okay, but in case of plastic impact, there is a loss of kinetic energy. So these are two special cases for the coefficient of restitution. One is E is equal to 1, this is called as elastic impact, and E is equal to 0, this is called as a plastic impact. Okay, so by using these two relations, one is conservation equation and second is the coefficient of restitution, we can determine the velocities VA dash and VB for the colliding move. Okay, so let us solve the problem on the first type, which is the direct impact. So the question given is a 2 kg ball moving with velocity 0.4 meter per second towards right collides with another ball of 3 kg moving with a velocity 0.5 meter per second towards left. So the condition given here, there are two objects or two balls, ball A and B. Ball A has velocity 0.4 meter per second. Towards right, and ball B has velocity 0.5 meter per second towards left. Okay. The mass of A, this is equal to 2 kg, and the mass of B, this is equal to 3 kg. Okay. So the question is, we have to determine the velocities of the balls after the impact and the percentage loss of kinetic energy. For three cases, the first case is impact is perfectly elastic, impact is perfectly plastic, and impact is such that the E value is 0.7. Okay, so let us solve the first case. Impact is perfectly elastic. So elastic impact means the coefficient of restitution value E is equal to 1. This is the perfectly elastic condition. Okay. Now when we solve the problem on impact, we have to use two equations. The first equation is conservation of momentum. So the conservation of momentum equation is initial momentum of the system. So MA VA plus MB VB. This is total momentum before impact. This is equal to MA VA dash plus MB VB dash. This is the momentum after collision. Okay. So here VA dash and VB dash, these are the velocities after the impact. So we have to determine these two values. One is VA dash and second is the VB dash. Okay. Now put the values given. The mass of A is given 2 kg. Second VA, this value is given 0.4. Now when we solve the problem of impact, the velocity is directed towards right, we should consider as a positive, and if the velocities are directed towards left, consider this as a negative. So VA is positive because it is towards right, plus mass of B is 3 kg into velocity of B before collision is minus 0.5. This is equal to mass of A it will remain same. So it is 2 kg. Va dash is unknown plus mass of B is 3 kg. Vb dash is unknown. Okay. So if you solve this, the equation as minus 0.7, this is equal to 2 Va dash plus 3 Vb dash. Okay. It means that the first equation is 2 Va dash plus 3 Vb dash. This is equal to minus 0.7. So consider this equation 1. Okay. Now we will use the second equation, which is the coefficient of restitution. So using the coefficient of restitution equation, so E is equal to Va dash minus Vb dash upon Vb minus Va. So as it is the elastic impact, which is the case 1, E is equal to 1. So 1 is equal to Va dash minus Vb dash divided by Vb minus Va. So this velocity Va is equal to, this is 0.4. Vb is equal to 0.5 on the negative side. So Vb is minus 0.5 minus Va is 0.4. So 1 is equal to Va dash minus Vb dash divided by minus 0.5 minus 0.4. So this is minus 0.9. Okay. So we will get the equation Va dash minus Vb dash. This is equal to minus 0.9. So this is equation 2. Okay. So equation 1 is Va dash 2 Va dash plus 3 Vb dash. This is equal to minus 0.7. So if you solve equation 1 and 2 simultaneously, then you will get the equation or answer for Va and Vb. So Va dash, that is velocity of A after collision, is minus 0.68 meter per second, and Vb dash is equal to 0.22 meter per second. So as Va dash is negative, it means that this is 0.68 meter per second after collision, but it is on the negative side. And Vb dash is positive, it means that velocity of B, it will be on the right after collision. So it is 0.22 meter per second. It means that after collision, so this is Va and Vb before collision. This is the impact, and after the collision, object A will start moving on the left. So this is Va dash, and object B, it will start moving on the right. So this is Vb dash. Okay. The second question is we have to find out the loss of kinetic energy. So when impact is perfectly elastic, that is E is equal to 1, the loss of kinetic energy, this is 0. Okay, it means that the kinetic energy for elastic impact before collision, this is equal to the kinetic energy after collision. So there is no loss of kinetic energy in case of elastic impact. Now refer the second case, which is the plastic collision. So case B, in the given problem. So for the plastic collision, the value of E, this is equal to 0. Okay. The meaning of plastic collision is both the objects after collision, they will move with the same velocity. So suppose this is the velocity A before collision. This is velocity B before the collision. When two objects collide each other, so at the collision point, they will undergo some deformation. So you can see the deformation here. And after that, they will move with the same velocity. So this is the velocity after the collision. Okay, it means that velocity of A after collision, that is a VA dash, is equal to VB dash, and that is the V dash. Okay, so they will stick together and they will move with the same velocity, that is the V dash. So for the plastic collision, the first equation we will use is the conservation of momentum equation. So conservation of momentum equation is MA VA plus MB VB. This is equal to MA VA dash plus MB VB dash. Okay. So in the given problem, the condition given is this is VA, this is 0.4, and VB, this is 0.5. Mass of A, this is 2 kg, and this is 3 kg. So conservation of momentum, mass of A, this is 2 into 0.4 plus 3 into minus 0.5. This is equal to 2 VA dash plus 3 VB dash. Okay. So from this we get the equation as 2 VA dash plus 3 VB dash. This is equal to minus 0.7. Okay. But we know that after collision the velocity is same. So we can VA dash is equal to VB dash, and you can put the value as a V dash. Okay. So from this we get 2 VA dash plus 3 VB dash. This is equal to 5 V dash. This is minus 0.7. And from this we get V dash is equal to minus 0.14 meter per second. Okay. So after collision, as the velocity is negative, it means that both the objects will start moving on the left side. So this is the impact. And after impact, both the objects will start moving VA dash. This is VB dash. Both are same. Okay. So they will move with minus 14 meter per second. So this velocity is 0.14 meter per second. Okay. Now let us find out what is the loss of kinetic energy. So for plastic impact, there is a loss of kinetic energy. To determine the loss of kinetic energy, we have to find out the kinetic energy before impact and kinetic energy after impact. So the total kinetic energy before impact, this is equal to kinetic energy of the mass A, so ma Va square, plus kinetic energy of the mass B, so mb Vb square. So this is equal to 1 by 2, mass A is 2 kg, and the velocity of A, this is 0.4 square, plus 1 by 2, mass of B is 3 kg, into velocity of B, so this is 0.5 square. So this total value is 0.535 Newton meter or joule. So this is the kinetic energy before impact. After impact, the kinetic energy, this is equal to 1 by 2, mass will remain same, only velocity will change. So Va dash square plus 1 by 2 mb Vb dash square. So this is equal to 1 by 2, mass is 2 kg. For plastic impact, Va dash and Vb dash both are same. So Va dash is equal to 0.14 square plus 1 by 2, mass of B is 3 kg into 0.14 square. So this total kinetic energy after impact is 0.049 joule. Now first find out the difference of kinetic energy. So loss of kinetic energy, this is equal to initial kinetic energy is 0.535 minus final energy is 0.049. So this is equal to 0.486 joule. And if you compare this value with kinetic energy, we can find out the percentage loss. So percentage loss of kinetic energy, this is equal to change in kinetic energy divided by the kinetic energy before impact into 100. So this is equal to 0.486 divided by initial kinetic energy is 0.535 into 100. So this value is 90.84 percentage. So when E is equal to 0, the loss of kinetic is 90%. So this is the answer for the second question. And for the third question or third case, the impact is such that value of E, this is equal to 0.7. Okay, so first equation is conservation of momentum equation. So mass of A, velocity of A plus mass of B, velocity of B, this is equal to mass of A, velocity of A after impact, so Va dash plus mass of B, Vb dash. Okay, so put the value mass of A 2 kg into velocity of A is 0.4 plus 3 kg into minus 0.5. This is equal to 2 Va dash plus 3 Vb dash. Okay, so from this we get the equation 2 Va dash plus 3 Vb dash, this is equal to minus 0.7. So this is equation 1. Okay, now use the second equation, which is the coefficient of restitution. So E is equal to VA dash minus VB dash upon VB minus VA. Okay. Now here E value is given, this is 0.7. This is equal to VA dash minus VB dash divided by VB minus VA. So VB is minus 0.5 minus VA, this is 0.4. VA is positive, only VB is negative because it is on the left side. So from this we get the equation VA dash minus VB dash upon minus 0.9 and E value is 0.7. Okay. From this find out the relation VA dash minus VB dash, this is equal to minus 0.63. So this is equation 2. Okay. If you solve equation 1 and 2 simultaneously, so you will get the answer VA dash is equal to minus 0.518 meter per second and VB dash is equal to 0.112 meter per second. Okay. It means that as the answer for VA dash is negative, the direction of object A, it will change. So this is 0.518 meter per second and it is moving on the left side. And VB dash, its direction will also change. It is already moving towards left. After collision, it will start moving towards right because the velocity is positive. Okay. So this is the first part, to find out the velocities after impact. Second part is we have to find out the loss of kinetic energy. So to find out loss of kinetic energy, first find out the kinetic energy before collision or before impact. So this is equal to 1 by 2 mass of A VA square plus 1 by 2 mass of B VB square. Okay. So if you put the value of mass and velocity, mass is 2 kg, velocity is 0.4 square plus 1 by 2, 3 into 0.5 square. So the kinetic energy before impact, so this is 0.535. Now the kinetic energy after impact, so this is equal to 1 by 2 MA VA dash square plus 1 by 2 MB VB dash square. So this is equal to 1 by 2 VA dash is 0.518 square plus 1 by 2 mass is 3 kg into 0.112 square. So this is equal to 0.287 joule. Okay. Now we can find out the percentage loss of kinetic energy. This is equal to the change in kinetic energy. So it is 0.535 minus 0.287. So this is the change in the kinetic energy upon initial kinetic energy is 0.535 multiplied by 100. So this is equal to 46.33%. Okay. So this is how we can find out the velocity after impact and the loss of kinetic energy. So to solve the problem on impact, the general procedure is first use the conservation of momentum equation. So use the equation MAVA MBVB. This is equal to MAVA dash plus MBVB dash. Okay. So if the velocity of the object is on the right side, take it positive in this equation. And if the velocity is on the left side, consider this as a negative. Second equation we should use, if E is equal to, which is the coefficient of restitution, VA dash minus VB dash upon minus VA. Okay. Only if E is equal to 0, so this is the special case, that is the plastic impact. We will not use this equation. Just we have to use the first equation for the plastic impact. And in this equation, we will put, if E is equal to 0, VA dash is equal to VB dash. You can put the value as a V dash. So for the plastic impact, directly by using first equation, that is the conservation of momentum equation, we can directly get the value of VA dash and the VB dash. For any other impact, if E is equal to 1 or if E range between 0 to 1, we have to use these two equations.